Download this code from codegive.com, link in the description below. OK, let's dive into 7 common assembly mistakes in Fusion 360 that can trip up both beginners and experienced users. I'll provide detailed explanations, example scenarios, and, where applicable, code snippets to help you avoid these pitfalls. This tutorial focuses on conceptual understanding and best practices. Directly coding in Fusion 360 is less applicable than understanding the logic behind joints and design. 1. Over-constraining your assemblies, the locked-in-a-box syndrome. The mistake applying too many constraints or joints, essentially locking components into fixed positions when you want them to move or have degrees of freedom. This makes the assembly rigid and prevents it from simulating real-world motion. Why it hurts. Over-constraining leads to frustration. Difficult to edit, update, or understand how components should move. Assembly errors. Fusion 360 may report errors, overdefined, or behave unpredictably. Limited analysis. You can't simulate the intended functionality of your design. Design restrictions. Difficult to adapt the design to new requirements. Example scenario. Imagine assembling a hinge. You might be tempted to add multiple revolute joints or fixed joints to secure the hinge leaves. Instead, you should only need one revolute joint at the hinge axis. Solution. Degrees of freedom, DOF, awareness. Understand the number of DOFs each component should have. Each unconstrained body has 6 DOFs, 3 translational, 3 rotational. Joints remove DOFs. Keep it simple, stupid. Use the minimum number of joints necessary to achieve the desired motion and constraint. Start with the base. Ground one component, usually the base or frame, using the ground feature, right-click -ground. This provides a fixed reference. Test motion early. After each joint, test the motion to ensure it behaves as expected. Right-click on a component and select Move/Copy to manually drag it around. Joint order matters. Consider the order in which you apply joints. Attaching a component to a grounded component first is often a good strategy. Use as-built joints sparingly. As-built joints are useful for simple connections within the same component, but they often fix geometry in place and can be limiting in dynamic assemblies. Code analogy, conceptual. Think of variables in programming. Over-constraining is like assigning multiple conflicting values to the same variable, leading to errors. In Fusion, multiple joints defining the same degree of freedom create the conflict. 2. Incorrect joint types, misusing the toolbox. The mistake. Using the wrong joint type for the intended motion. For example, using a rigid joint when you need a revolute joint. Why it hurts. Components won't move as intended, and the assembly will fail to represent the actual mechanism. Example scenario. You want to model a drawer that slides in and out of a cabinet. Using a rigid joint will lock the drawer in place. You need a slider joint. Solution. Understand joint types. Review the different joint types and their effects. Rigid. Completely fixes components together. No relative motion. Revolute. Allows rotation around a single axis, like a hinge. Slider. Allows linear translation along a single axis, like a drawer slide. Cylindrical. Allows both rotation around and translation along a single axis, like a shaft in a hole. Pin slot. Allows translation along a slot and rotation around an axis perpendicular to the slot. Asterisk planar asterisk allows translation along two axes and rotation around an axis perpendicular to the plane. Asterisk ball asterisk allows rotation around all three axes. Asterisk visualize the motion asterisk before creating a joint, visualize how the components should move relative to each other. Asterisk test with move/copy asterisk after creating a joint, use move/copy to drag the component and visually verify that the motion is correct. Asterisk edit joints asterisk if you choose the wrong joint type, you can edit it by double-clicking the joint in the timeline or the browser. Asterisk code analogy asterisk choosing the wrong data type in programming. Using a rigid joint when you need a slider is like trying to perform mathematical operations on a string. 3. Ignoring component origins, the floating in space problem. Asterisk the mistake asterisk not paying attention to the component origins, the coordinate system at the center of the component, when creating joints. This leads to components being misaligned and potentially difficult to constrain. Asterisk why it hurts asterisk. Asterisk misalignment asterisk components may not be positioned correctly relative to each other. Asterisk difficult joints asterisk creating joints becomes harder because you're trying to align components from arbitrary locations. Asterisk assembly errors asterisk misalignment can lead to joint errors and unexpected behavior. Asterisk aesthetic issues asterisk the assembly will look unprofessional. Asterisk example scenario asterisk you're assembling a table. The legs should be attached symmetrically to the tabletop. If the leg origins are not carefully placed, the legs may be offset or rotated incorrectly. Asterisk solution asterisk. Asterisk origin placement asterisk when designing components, place the origin thoughtfully. Consider the component's center of mass, symmetry, or a key feature that will be used for assembly. Asterisk joint origins asterisk when creating a joint, carefully select the origin points, joint origins, on each component that you want to align. Use the select origin command in the joint dialog to refine the placement. You can even create custom work planes or points specifically for defining joint origins. Asterisk visible origins asterisk turn on the visibility of component origins in the browser, click the eye icon next to origins under each component. This makes it easier to see where your joints are being placed. Asterisk align command asterisk before creating a joint, use the align command, modify -align, to roughly position components. This helps reduce the distance the joint needs to move the component, making it less likely to fail. Asterisk coordinate system awareness asterisk be mindful of the coordinate system directions, x, y, z, when creating joints. For example, the axis of a revolute joint should align with the intended rotation axis. Asterisk code analogy asterisk incorrect relative coordinates in graphics programming. If x2 and y2 are relative to a different origin than x1 and y1, the calculated distance will be incorrect. Similarly, if your components have inconsistent origins, the assembly will be incorrect. 4. Ignoring assembly context, top-down versus bottom-up. Asterisk the mistake asterisk not thinking about the overall assembly structure and design approach. Two common approaches are asterisk top-down asterisk designing components in place within the assembly. Asterisk bottom-up asterisk designing components separately and then assembling them. Mixing approaches haphazardly can lead to issues. Asterisk why it hurts asterisk. Asterisk design dependencies asterisk top-down design can create strong dependencies between components, making it difficult to modify individual parts later. If one component changes, it can ripple through the entire assembly. Asterisk component organization asterisk lack of planning can result in a disorganized assembly tree, making it difficult to find and edit components. Asterisk version control issues. Asterisk managing components designed in place can be more complex in version control systems. Asterisk example scenario. Asterisk you start by designing a housing component in the assembly. Then, you design a gear that must fit perfectly inside that housing. If you later modify the housing, the gear may no longer fit, and you'll have to redesign it. Asterisk solution. Asterisk choose an approach. Asterisk decide whether you'll primarily use top-down or bottom-up design. A hybrid approach is often best, but be mindful of the potential issues. Asterisk top-down best practices. Asterisk use empty components as containers to organize your design. Asterisk use project to surface to create sketches on existing components to define the shape of new components. Asterisk use derive to create a copy of geometry that updates when the original is changed. Asterisk be careful about creating features that cut across multiple components. These create strong dependencies. Asterisk bottom-up best practices. Asterisk design components to standardize dimensions and tolerances where possible. Asterisk create a detailed assembly drawing or plan before you start designing individual components. Asterisk use parameters to control key dimensions across multiple components. Asterisk establish a component library. Asterisk create a library of commonly used components, example fasteners, bearings, to promote reusability and consistency. Asterisk code analogy. Asterisk unstructured code versus modular code. Modular code, bottom up, is easier to maintain, test, and reuse. 5. Lack of parameters, missing the power of parametric design. Asterisk the mistake. Asterisk designing assemblies with hard-coded dimensions and without using parameters. Asterisk why it hurts. Asterisk difficult to modify. Asterisk changing a dimension requires manually updating multiple features, increasing the risk of errors and wasted time. Asterisk no design exploration. Asterisk impossible to quickly explore different design variations by changing a single value. Asterisk inconsistent designs. Asterisk difficult to maintain consistent dimensions across multiple components. Asterisk example scenario. Asterisk you're designing a table, and you want to easily adjust the height. If you've hard-coded the leg length in multiple sketches, you'll have to change each sketch individually. Using a parameter called table height would allow you to change the height in one place. Asterisk solution. Asterisk define parameters. Asterisk use the change parameters dialog, modify -change parameters, to define named parameters for key dimensions, angles, and other design variables. Asterisk use parameters in sketches and features. Asterisk instead of typing in numerical values, use the parameter names in sketches and feature definitions. For example, instead of entering 100 mm for the length of a line, enter table height. Asterisk equation-based parameters. Asterisk use equations to define parameters that are dependent on other parameters. For example, leg thickness equals table height /10. Asterisk spreadsheet integration. Asterisk link parameters to a spreadsheet for more advanced design calculations and data management. Asterisk user parameters versus model parameters. Asterisk be aware of the difference. Model parameters are created automatically when you dimension something. User parameters are manually created, giving you more control. Asterisk code analogy. Asterisk hard-coded values versus variables and constants. Using constants and variables makes the code more readable and easier to modify. Parameters do the same for Fusion 360 designs. 6. Improper use of copy/paste versus patterns, duplication dilemmas. Asterisk the mistake. Asterisk copying and pasting components repeatedly instead of using patterns, or vice versa using patterns for something that is unique. Asterisk why it hurts. Asterisk Asterisk difficult to update asterisk if you copy and paste a component multiple times, and then need to change the original component, you'll have to manually update each copy. Asterisk complex assembly tree asterisk a large number of individual components can make the assembly tree unwieldy. Asterisk inconsistent spacing asterisk using copy/paste makes it difficult to maintain consistent spacing and alignment. Asterisk overuse of patterns asterisk patterns can become computationally expensive if overused or if the components are complex. Asterisk example scenario asterisk you need to create a grid of holes on a plate. Copying and pasting the whole feature multiple times would be tedious and error prone. Using a rectangular pattern is much more efficient. On the other hand, having multiple patterns with a very small number of elements is a waste. Another example is, having 4 legs on a table, a mirror pattern may be a better and easier solution. Asterisk solution asterisk. Asterisk use patterns for repetitive features asterisk use rectangular, circular, and pattern on path features, create dash pattern, to create multiple instances of a feature or component quickly and easily. Asterisk component patterns asterisk you can pattern entire components, not just features. Asterisk mirror pattern asterisk create mirrored copies of bodies or components across a plane. Asterisk use the copy feature with paste new asterisk if you need a completely independent copy of a component, use the copy command, then right-click in the assembly and select paste new. This creates a new component that is not linked to the original. Asterisk evaluate the trade-off asterisk consider the trade-off between the computational cost of patterns and the update difficulty of multiple copies when deciding which method to use. Asterisk rename components asterisk after pasting, make sure to rename components appropriately. The default names, example component 1:1, can be confusing. Asterisk code analogy asterisk repeating code versus loops and functions. Loops and functions make the code more concise and easier to maintain. Patterns do the same for Fusion 360 designs. 7. Forgetting about interference and collisions, the things crashing into each other issue. Asterisk the mistake asterisk not checking for interferences or collisions between components in the assembly. Asterisk why it hurts asterisk. Asterisk manufacturing problems asterisk interferences can prevent the assembly from being physically assembled. Asterisk design flaws asterisk collisions can indicate that the design is not functional or that components will wear out prematurely. Asterisk incorrect simulations asterisk motion studies and simulations will be inaccurate if collisions are not accounted for. Asterisk example scenario asterisk you're designing a robotic arm. If the arm segments collide with each other during motion, the robot will not function correctly. Asterisk solution asterisk. Asterisk interference check asterisk use the interference command, inspect dash interference, to identify any parts of components that are overlapping. Asterisk contact sets asterisk define contact sets, assemble dash enable contact sets, to prevent components from passing through each other during motion. Contact sets can be computationally expensive, so use them sparingly and only where necessary. Asterisk motion studies asterisk use motion studies, design dash motion study, to simulate the motion of the assembly and visually check for collisions. Asterisk joint limits asterisk set joint limits on revolute and slider joints to restrict the range of motion and prevent collisions. Asterisk visual inspection asterisk carefully visually inspect the assembly from different angles to identify potential interferences. Asterisk code analogy asterisk collision detection in game development. Collision detection is essential for creating realistic and functional simulations. Key takeaways and best practices asterisk. Asterisk plan your assembly asterisk think about the overall assembly structure, degrees of freedom, and design approach before you start creating joints. Start simple. Build up the assembly incrementally, testing the motion after each joint. Use parameters. Take advantage of parametric design to make your assemblies more flexible and easier to modify. Check for errors. Regularly check for interferences and collisions. Keep it tidy. Rename components and organize the assembly tree for clarity. Document your design. Add notes and comments to explain the design intent and the purpose of specific joints and features. Learn from your mistakes. Everyone makes mistakes. The key is to learn from them and avoid repeating them in the future. By being aware of these common mistakes and following the best practices outlined above, you can create more robust, functional, and maintainable assemblies in Fusion 360. Good luck.